So dear friends, you know, water is very important in our day-to-day life. We can't survive without water. So for manufacturing process, different types of industries, water is most important and required too much. So after using or manufacturing manufacturing process, the remaining water we cannot treat, but it can be directly transferred to the open sources. So it's our responsibility to treat this water and can be reuse this, so that the this water can be fulfill the extra demand of water, and also can be used for various purposes like industrial purposes, like gardening purposes, also for the agricultural purposes. So speaker, Dr. Sandeep Mai sir, who is the HOD of Civil Engineering Department, Pimpri Chinchwad College of Engineering. Dr. Mai sir completed the PhD from Savitribai Phule, Pune University, and having 18 plus years of experience in lectureship. Also, sir guided to the PhD students and also MTech students. Sir also having a consultant for many agencies and co-author for many number of books. Sir also published 15 plus years paper in international journal, and also 3 paper in national journal. Sir also attended 13 international conferences and 25 national conferences. So I request to our principal sir, Dr. Patil sir, please guide and welcome to Dr. Mai sir. Thank you.
Hello.
Hello. Yes, sir. Yes, you are sir. Audible.
Yes. On behalf of some other group of institutions, I heartily welcome to Dr. S.T. Madi sir, HOD PCCV of Civil Department, for today's webinar. Just Madam explained eco-friendly solid state treatment. As you know that how water is valuable, it's such a preciable asset for us, for human being, not only for asset, but it is a need to your daily survival. Because if you don't have food or your nutrition, you can survive so many days. And without water, but without water, you cannot survive even for more than 2-3 days. Or means how water is important for us, for living being, not only for human being, but for every living being. And everyone is aware that the available water on our earth is only 1 or 2%, and all the wet water available through ocean and all that. So apart from 100% water, we are available only 1% water, and day by day our population of not only our India but for the world is increasing so vastly. So around 600 crores people are living. 600 crores people are living on our earth. What I mean to say here that how water is precious for everybody, and we are wasting that water wasting such a bluntly. No one has care over that, and no one is taking the care. And आपल्या मराठीत म्हण पण आहे की पाण्यासारखा पैसा खर्च केला की पाण्यासारखा पैसा, म्हणजे त्याला आपण उपमा अशी देतोय की वी आर गिव्हिंग दॅट अ प्लेजर, पाण्यासारखा पैसा केला. We can achieve the money. Much money, but at that time we don't have water. How this valuable water is there, and how we are wasting is that. So what to do, whatever water we are wasting, to reuse that. So, so what we are living in an age of technology, and in that age of technology, how technology can be used to treat your use water, or to what you call it as a solid waste, whatever wastage of water we are doing daily. So there are so many methods are available there. Sir will explain all to you. And apart from that, everyone is going on an eco-friendly treatment or green energy eco-friendly. There should be no chemicals, no any other treatment to treat that water. And that, as you know, that in so many states of our India, like Punjab, our water table is also polluted due to the fertilizers and all that, due to this solid waste of whatever we are wasting. Everything we are giving to the river water, or we are making to the river water very polite there, day by day. And because of that, our all the health and so many problems. Now I will not discuss all that problem. So what will be the procedure, and what should be human being as a good human being, or technology or as an engineer, to treat this solid water, that it may be used not only for it could not suppose use for the potable water or for drinking water, but for so many purposes here. That water we can use for other purposes, which is not related to your directly health. So what technologies, what methods to do for this waste water as a usable water there. So Sandeep sir will explain you all of that. So I again welcome to him, and again thanks to him for sparing his valuable time and giving such a valuable information to you. So I thanks on behalf of our chairman sir, our secretary sir, and all the staff members of civil department, HODs from our college student also. Thank you very much. Thank you, sir.
Okay. Now I request to Dr. Mahi sir, please guide our students, and thank you.
Yeah. Good afternoon. Am I audible?
Yes, sir.
Yeah. Just give 1 minute so that I will share my screen, and then I will start. Yeah. So hope I am clearly audible to everyone, and my screen is visible to you.
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
Yeah. Thank you. So first of all, good afternoon to all of you. Respected Principal A.J. Patil sir, Samarth Group of Institutions, College of Engineering, Belne, Priyanka Golab, faculty members from Department of Civil Engineering. So first of all, I give thanks to all the principal and the faculty members for giving me an opportunity to have a discussion with the students of the Civil Engineering Department. I have some memories with these institutions. Might be in 2007. I have taken some session in your college for the students for the course of water supply engineering, and even I have some photographs with the students of the your institutions, where we had a visit to the one of the water treatment plant nearer to the your city. So I have some memories with the institutions, and I was there for 1 or 2 days in your institution. So there are some special memories with respect to your college. So once again I have, yeah. So once again I have got an opportunity to have an interaction with the students, and rightly mentioned by the principal A.J. Patil sir, the need of the topic and the importance of the water which we are having. And recently we have celebrated the World Water Day, right? And in a civil engineering course, in 3rd year civil engineering, they are studying about the water supply engineering, as well as in a semester 2, they are having a wastewater engineering. Okay. So once again, I thank, and now I will go to the this topic. Now today I'm going to speak about the eco-technology for the wastewater treatment. Now let's see the water, which we say it is a life. And as the principal sir said, without the water, 2 days may not be possible. So it is one of the important component of the human life is the water. And as you know, the 70% of the entire earth is a water. But out of that, only 1% it is for the drinking purpose. And even our body, it is having a 70% of the water is this one. But when we consider from the engineering background or the scientific background, now these are the quality parameters of the water. They are defining whether it is a good quality of water or the bad quality. And these are the limits which is defined by the Bureau of Indian Standard 10,500-2012. So they are the standards. So when we purchase any mineral water bottle, there is a BIS standard that has been mentioned. Means it is within the permissible limit that has been. For example, the pH is going to be between 6.5 to 8.5. The turbidity is 1. So what you do, all the water quality analysis into the laboratory, they are having a significance. That is important. And based upon that, the decision you are going to take it. So this is about the water. Now, when it comes to the next wastewater, now we have seen the water. Though we say it is a water, it is a H2O, pani, and all these things. Now, what about the wastewater? Now, the wastewater is going to change the characteristics. Now, when we say it is the water is representing these characteristics. Now, any other characteristics apart from the water and which are going to be above the certain values, then we are going to call it as a wastewater. Now, now related to the wastewater, when the analysis it is done for the entire India, and then it is observed that the characteristics, that is a minimum, average, and the maximum, that is going to be representing. Now, for example, when we consider in terms of a COD value, the minimum value is having a 138 and maximum it is having a 381 is the maximum value it is going to be there. Okay, so these are the characteristics. So in a wastewater engineering, you are doing this kind of analysis. Now, for example, it is having the solids. The solids, they vary from 280 to the 595. So all these characteristics, they represents the wastewater. Now, let I take to the, there are certain health issues, the problems and the challenges are there. Okay, so what are the problems and the challenges? So it is stated by one of the author, sewage can lead to another disaster. So you are able to see it is a disaster. So when we say it is a disaster, it is for all the human beings on the planet or on the earth and anything. So which is nothing but the disease is going to be called. And there are so many health impacts are going to be there. Now I want to take to some of the statistics or the questionnaire or observations. 1 minute. So Priyanka madam has shared the screen with you. Shared the Google form with you. Now I want to take certain questions from your students that might be present. They have asked it one. Now I want to take the questions which are there. Okay. Just I will make a zoom so that you will be able to clearly see. So my screen is visible to you. Yeah. So for example, the Akshada C is asking what are the problems that can be expected with an installed STP. Then another question by Akshada, how can treated sewage be recycled or reused for the various purpose? And then the Gayatri is asking, why not consider grey water treatment seriously in spite of the extra space it requires? Okay, so here the treatment of that one. Then Nikodi Priti Sandeep is going to ask how many percentage we get pure water from the wastewater treatment plant. Okay. Then Nikita is asking if the water is toxic, then can we use it for the agricultural purpose? Okay. Then Kanchan is asking, is the treatment of sewage rather complicated to understand to an average resident or the owner of the apartment or a villa? Okay. And then the Pallavi is asking, what can a resident association do if it necessitates, if it needs experts' help to sort out the problems with the sewage treatment? So these are some of the few representative questions are there which are related to the sewage, or you can say it is related to the wastewater. And we are going to see the answers of these all questions into this one. Okay. Now, as you know, the wastewater is generated from the various activities, and all these wastewater you should know as an engineer. That is a domestic wastewater, the hospital sewage, the agricultural effluents, and the industrial wastewater. These are the sources. Then what is the statistics about the wastewater in India? Now the central government, that is the Ministry of Environment and Forest and the Climate Change, and the NERI, that is the National Environmental Engineering Research Institute, they have carried out this study and they have classified the cities into the cities class 1, class 2, and the class 1 and class 3. And they have given us statistics about the sewage generation. For example, if I consider the class 1 city, this is the wastewater quantity generated. That is a 35,558 million tons that is going to be generated. Okay. And as you are able to see the capacity of the install, and the capacity gap is this much, that is a 68%, 92%, and 70%. And here the civil engineering, the scope is there. So here it is a government sector as well as the private sector. They are working on this so that there will be a sewage treatment facility so that it will reach to the 100% is going to be a possible to reach it. Okay. And for which there is a very huge demand of the civil engineer having a knowledge of the wastewater engineering, and they will be able to implement. That is the importance. Now, at a central level, that is a Ministry of Jal Shakti and Department of Drinking Water and the Sanitation. They are working on this sector. Now, already you have studied about the water supply engineering, and the second part, it is a wastewater engineering. Okay, that is nothing but the sanitation part. So, which is going to be taken care. Okay, and here it is mentioned. For example, for the water, 6 crores rural household gets the tap water. Now, as they are getting a water, obviously after its usage, around 75 to 80%, it becomes the wastewater, and that needs to be treated. And due to which, under the sanitation, or you can say the Swachh Bharat mission, and there are urban as well as it may be a Gramin. Okay, that is for the rural sectors. So in which there are so many things they have mentioned. And if you see, they have mentioned the two parts relevant to this. That is a grey water management. That what we say it is a wastewater or it is a sewage. Or another thing, it is a fecal sludge management. That is a wastewater or the sludge coming from the toilets. That is called as a fecal sludge management. So that needs to be done. And that is the technology which we are going to study. It is the grey water, eco technology. Now here it is a journey of what? It is a water which is in a pure form, which we are using for so many activities or for the regular activities. And after the usage, it becomes a wastewater. And that we have seen in terms of quality parameters. Through the laboratory test, you are determining it. So about 75 to 80%, it becomes a wastewater. And as an engineer, we want to again convert into the water. So it is a journey of a water from wastewater to the water, that which we are going to study. And here, why it needs to be studied, or why this, what is the importance of this session? So you are as a civil engineer, you are studying this one. And after completion of your course, you are going to work either in a government sector or you are going to work in a private sector, or you are going to have your own business where you are going to convert this wastewater into the drinkable form, into the water, which is a important component of the nature and all these things. Okay, so this you are going to study. Okay, so this is a journey of wastewater to the water, which we are going to study. Now, how this journey, that our aim is what? We want to convert this wastewater into the water, that is into the natural form. We want to convert it. Now, how it will be get converted? Now, this is a journey is there one. Now, the journey, it is going to be in two terms. That is, it is having the unit operations. That may be a physical things. Okay. So, for example, it is a screening, sedimentation. Okay. So, these are the mechanism. These are the unit operations. And when it is a unit process, it is a biological or the chemical changes you are going to do it. Okay. In the wastewater. Now, when we say it is a wastewater, actually, now in a wastewater, as you have studied, it is 99.9%. It is the H2O. That is, a water is there, and 0.1% it is only the solid, and this 0.1% is causing the pollution or the impurities, and which we want to remove. So this is 0.1%. And this 0.1% impurities, they are going to be get removed through this unit operations or the processes, which we are studying in the wastewater engineering. Now, after this, what are the other processes are there? Now, this process operations and the processes, they are classified into the four groups. The first is the preliminary treatment, then primary treatment, secondary treatment, and the tertiary treatment, where these impurities, 1.1% impurities, they are going to be getting removed depending upon the nature. The sequence is this one. The first is the preliminary, second is the primary, and the third it is the secondary, and the fourth it is having a tertiary. Now, there are different types. The first is the physical, chemical, biological, and the final treatment is there. Now, some of the treatments already you have studied it, and in today's session specifically we are going to see this part, that is a biological part, and the secondary treatment, and it is with respect to the ecotechnology that which we are going to see it. Okay, so these are the treatments, physical, chemical, biological mechanisms are there. The physical is nothing but these are the sedimentation, that is a gravitational force is the predominant. Now, for example, sand, silt, clay, they are going to be. Now, when it comes to the chemical and the biological, there are suspended and dissolved impurities are there, which are not possible to remove through the physical mechanism. And for that purpose, it is the chemical or the biological mechanisms are there, where they are going to get converted into the biomass or the settleable forms, and they will get removed. So, which we are going to see it. Now, let's comes to the example of the effluent treatment plant. So, on this slide, you are able to see the flow chart, the company, the mechanism, how it is going to operate. And there are going to be the mechanisms. So, here it is a effluent treatment plant, is a mechanism. So, through which there is a purification or the removal of the contaminant is going to operate. So that has been represented here. That is the example. Now let's comes to the types of the wastewater treatment plant. Now this wastewater treatment plant, they has been classified into the three groups. One, it is a centralized, the first, and second is the decentralized. Now what do we the centralized the system, where you are able to see the wastewater generated from all the areas, they will be brought to the one point, that is called as centralized. Then the decentralized is nothing but the various STPs, it will be located at a different locations. Now for here, it will be only one wastewater treatment plant, and this will be the different 4 wastewater treatment plant. So this depends upon the areas and all these things. whenever the population is less and all these things. Now, for example, in your case or your location, so centralized system may be preferred. Now, in case of the metropolitan cities or the urban, where the large areas are there, then in that case, the decentralized cities is the decentralized wastewater treatment facility. Now, coming to the next, that is the on-site and the off-site treatment facility. Now, for example, college.
ठीक आहे 12:30ला ब्रेक घ्या
Hello,
जेवण करून या तुमचा टायमिंग त्यांना सांगून 12:30ला ना एकचा टाइम अर्धा तास तुम्ही म्हणा मी 15 मिनिटं बरोबर हे करता 1 वाजेपर्यंत या म्हणायचं सगळ्यांनी पटकन जेवण
Hello, Priyanka madam, can you
क्लास मध्ये करा म्हणायचं तुमचं बाहेर इकडे तिकडे फिरू नका
आशिष पुलवडे
Yeah. So thank you. Now we are seeing the types of wastewater treatment plant. The second, it is related to the on-site and the off-site treatment facility. Now, for example, your college or the institute premises, you can say it is an outskirts. So there is a, you can provide the on-site treatment facility only for that locality. Now, off-site means it will be the combination of your institutions and nearby area. Then based upon the cost economics, they are classified into the conventional and the low cost treatment facility. So these are the different types of the wastewater treatment plant. Now, as we have seen, some problems and the challenges are there. Now, these problems and the challenges in the management or treatment of wastewater treatment plant. The first is the population. The population, more the population, the problem it will be more severe. The quantity of wastewater generated. If it is more quantity, then again less quantity, more quantity. That is again a problem. Then the quality of a wastewater that you can be able to see. It is if it is highly concentrated, then it is very difficult to treat it. Then area availability. Now, for example, my college premises, it is in Pimpri-Chinchwad Corporation. The available area is less. But when I go to the semi-urban area or the rural area, the availability of the area is more and they are less costly in a comparison to the city area. Nowadays, the electricity or the energy, okay, there is a load scheduling in Maharashtra. So this is also one of the point. Now, when we are going to suggest the treatment facility, if it is required the electricity, then that needs to be taken into the consideration. Now, coming to the next, finance. So that does the finance that much is available or not? The next, the skill manpower. So these are the various points or the factors that needs to be taken into the consideration while deciding the type of a treatment that is to be considered. Now let's see, as an engineer, we are going to have the technical comparison as well as other comparison. Now let we divide the entire area for any country or for any state. It may be the urban area, semi-urban area, and the third is the rural area. And these are the points or the parameters, okay, which you are going to compare. And then you will do the comparison. And based upon the comparison, then you will do the analysis. And based upon the comparison and the analysis, you will be able to take a decision, that one, which type of the treatment facility it will be get into the consideration. Now, for example, you want to purchase any kind of a product. So you can do the comparison between the Amazon, Flipkart, the C-Link, that one. There are so many options. You are doing the comparison, analysis, and then you will be taking a decision. So as an engineer, you will do this one. Now let's comes to the, after this, taking a decision, type of a treatment and where you are going to provide it. Now let's see what is the eco-technology. Now, as an engineer, you know what to by the engineering and the technology. So when you consider the technology, it is going to be an application where onto the site. Now you know that we have seen water, wastewater, we have seen the treatment. Now we are seeing it is a eco-technology. Now this, as per the standard book definition or the Google definition, you can see the eco-technology is defined as It is an ecosystem management based on the deep understanding. So you need to have a deep understanding of what the principles of what you can see unit operations and the processes on which the natural ecological system are built on the transfer of such principle into the ecosystem management and in a way to minimize the cost. So here the cost is one of the parameter and measures their harm to the global or the environment, and it is going to be the less harmful to the environment. So this eco-technology is a technology which is the cost wise it is a less costly and it is not harmful to the environment. It is not causing the impacts to the environment. So due to which nowadays the eco-technology is going to be getting preferred. Now another thing, you are going to have the comparison between the biological systems as well as the non-biological systems. Now when I consider the non-biological systems, where it may be the chemical systems, it may be the physical system, or it may be the blend system or the hybridization. So the comparison it is going to be done, and based upon there are certain so many advantages and they are going to be there with respect to the optimization and design parameters, mechanism of synthesis, usage, environmental concerns, durations, and all this. So considering all these parameters, the eco-technology is generally preferred for the domestic wastewater as well as for some of the industry. These are the eco-technology. Now, when we consider the eco-technology, the examples, they are the activated sludge process, then it may be the trickling filter, aerated lagoons, oxidation ponds are there going to be there. Okay, so let I want to take before the taking the principles. So what are the, which are the eco-technologies are there? Okay, so that needs to be understood. So these eco-technology, they are classified into the three groups as per my perception. Now what the application area, it is the urban area, industry, and the centralized system. Now the examples are the activated sludge process, trickling filter, sequential batch reactor, rotating biological contractor. So this is for the urban area. Now when it comes to the semi-urban area, where the population is the lesser, the quantity is lesser, the characteristics are the different one. The area availability is more in a comparison to the urban area. So in such cases, the preferred eco-technologies are the aerated lagoon, oxidation pond, anaerobic lagoon, USBR. These are the technology. Now, when you consider the population is very less, that population it is having hardly 1,000, 2,000, 3,000. Even there are availability space is the larger one. The industries which will produce, it is the only the organic waste. Okay. Or when you want to have a decentralized system. So in such case, the different eco-technologies available are the phytoremediation, packaged sewage treatment plant, and the modified septic tank. So these are the different treatment options are available. Okay, so where you can treat it and where you can after treatment and disposal. Now amongst this, there are going to be, these are the treatment technology. Now we need to understand there is going to be a purification. Now as I can say, there is a 0.1% solids. These are causing the impurities, 0.1%. And there are dissolved solids, suspended solids, and the solids. Now these solids, they needs to be converted into the biomass or the solid form, where they will be able to settle, okay, due to the either physical force or the natural force, and they will get. Now here the role of a hero or the conversion from the suspended or dissolved form to the settleable form, it is done by the microorganisms. So they are the real heroes of this purification, I can say. So for which we need to understand the wastewater microbiology and how they are going to cause the purification. So let's see one video related to this, where the purification is going to get it occur that. Okay. So I have shared my screen with you. So hope you are able to see the video.
Is that what I think it is? A lot of people mistake wastewater treatment biosolids for something, well, a bit different. So what is that stuff? And where did all of the, go? Well, what you see here is sludge or biomass. It ate the, reproduced and then died. One primary purpose of a wastewater treatment plant is to accelerate nature, specifically to develop specific conditions to grow some special bugs. So what are these bugs? All of the bugs being grown in the wastewater treatment plant are natural and perform the same tasks, albeit in a little less dense populations, in water and soil around the world. The vast majority consists of various populations of bacteria who perform the bulk of the wastewater treatment process, such as BOD removal, nitrification, denitrification, phosphorus uptake, and so on. Generally, these bacteria are pretty boring to look at under the microscope. But not all of them are boring. Looking at a sample under the microscope will, in fact, reveal some other more exciting guys. They don't really contribute much to the overall process, but can play an important role in process control. So who are these guys? Let me make a note here that some of these guys will vary from process to process, so you'll have to get to know your own population. Let's take a look at a family called Stoxiliates first. Here we have a couple varieties that we're going to talk about. First is Vorticella. These guys attach onto a block of bacteria and have a retractable tail. They can be pretty quick. Then there's Epistylus. Similar to Vorticella, Epistylus also uses his tail to latch onto bacterial flock formations. However, this guy's a little bit more passive and does not have the retractable feature, so he doesn't move around as much. Now to the family of the free-swimming ciliates. These guys also come in a few different varieties. Here's an Aspidisca. These little critters are easily identified by their many crawling legs. Say hello to Lytonitis. I don't know if I pronounced that correctly. And here is Trichophyllum. Look at this guy go. Ah, yes, and rotifers. These are a higher life form with cool, hairy mouths and are much larger than many of the other bugs we see here. Some forms are much more mobile and move around constantly. Others, a little bit less active. On our worm friends, the nematodes. These tiny worms, who can be active or just swimming lazily around the neighborhood, can also be an indicator of some certain conditions. Both nematodes and rotifers can be indicative of an older bacterial biomass, and in wastewater are indicative of a higher degree of purification or seeding from an attached growth system. Another important bacteria to note are called filamentous bacteria. These include Microthrix parvicella, Nocardia, Thiothrix, and a whole bunch of other characters with no names but are classified as type blank, like type 0914. As you would expect, filaments can also be used to identify conditions of sludge. There is a whole suite of indicator tests available to identify which kind are present in your sludge. So, do we care who's in our process and how many of them there are? Great question. The answer is yes. Here's why.
Researchers in England several years ago evaluated the presence of and identified the potential effluent quality you would see. For example, Vorticella and Epistylus are seen normally with high-quality effluents, whereas Opiculera is seen more often in a lower-quality effluent. This English study was updated to reflect the condition for nitrification in a wastewater treatment plant. And what they did was compare what particular ciliated organisms were present when nitrification was occurring and what organisms were present when it was no longer nitrified. In the second study, a table was prepared, and it showed the abundance of organisms that are more likely to reflect nitrifying conditions versus those that are present when non-nitrifying conditions occur. In all of these studies, It was stressed by the researchers and should be understood by anyone using this identification technique that the relative abundance will probably change based upon the specific operating conditions and the wastewater stream characteristics for each and every wastewater treatment plant. As such, the tables provide a good starting point, but should only be used as a starting point. And if one wants to be certain what's going on, they develop the table for their own facility. Using these studies, one can see that when you see critters such as Vorticella, when you see the shelled amoebas, when you see some types of rotifers, you see those only when there's low BOD present in the wastewater. It's not always the case, but it's usually an indication that those conditions are present. The best solution for any wastewater treatment plant is to do their own analysis, prepare their own tables. And if you do that, you'll be able to use the stoxylians, the rotifers, and the amoebas to indicate what is happening and possibly predict the future of when it's going to change.
As previously touched upon, filament tracking can be another powerful tool to monitor conditions in a wastewater treatment plant. The abundance and type of filaments present can indicate various process conditions such as low dissolved oxygen, low F to M ratio, septicity, excessive grease and oil, nutrient deficiency, and low pH. Tracking filaments requires the use of staining tests, tests for sulfur granules, cell size, and presence of septa, as well as identification of attached growth on the filament. Jenkins, Richards, and Diager developed a chart to use in the evaluation process. With sufficient testing, the exact filament can be identified. The dominance of a filament indicates the operating conditions. If you want to change the biomass, change the underlying conditions which supports that filament. For example, type 1701 indicates a low DO, where type 1851 indicates a low F to M ratios. So what physical parameters can very well correlate with your microorganism populations? Well, the following list is a good beginning. SVI and settling rates, temperature, BOD, TSS and nutrient removal rates, dissolved oxygen levels, F to M ratios, wasting rates and SRT, mixed liquor concentration, pH, and the presence of pollutants. Once you identify and track indicator organisms, you can change the conditions you have control of, such as the mixed liquor concentration, aeration, RAS flow, pH adjustments, and nutrient deficiencies. It may take some effort, but it could help you do what you do better. And the better you operate, the cleaner the water. And that makes it all worth it.
So this was about the wastewater microbiology. It is something fundamental that we need to understand. That suppose we have a breakfast, okay, in the morning. We take our food that goes to the stomach, and we say the digestion is going to occur there. Now, this digestion phenomena is done by the microbial. Our body itself is a aerobic system is there. So we take air for the oxygen. We are having a water. We take it as a food. All things we are going to take it, and they are going to be done the digestion. Now, this digestion phenomena, it is a biological as well as it is a chemical. Now, when we are seeing this wastewater, actually these solids, they are considered as a carbon, hydrogen, oxygen, nitrogen, and the sulfur, CHNOS. These are the compounds, and they are going to be get converted into the various forms by this mechanism, and that is nothing but the microbiology. Why I will showcase the video to you. These are the microorganisms which are doing a purification mechanism or the contaminant removal mechanism, and they are not going to be visible to the naked eyes. But what exactly happening the micro level phenomena? So that was showcased through this video. Then, as we have seen, these are the different types of technologies based upon the applications and the domains. Now, let's see the principle of the ASP, that is the activated sludge process, which you might have studied. Now, in an activated sludge process, the name itself, why it is activated, the word activated, when the MLSS concentration, that is a mixed liquor suspended solid concentration, is between 3000 to 5000 milligrams per liter, and they are in the growing stage, that is called as an activated. Now what about the sludge? Now this sludge is from the secondary sedimentation tank, which is settled at the bottom. And why it is a process? Because the process is nothing but when there are going to be some biological as well as the chemical changes are going to occur with this system, that is called as an activated sludge process. Now how it is going to occur? Now you are able to see it is the you are able to see this is a flow sheet of the activated sludge process, in which the raw water after the primary sedimentation tank it is taken, then it will go to the aeration tank, and then in the aeration tank these are the microorganisms what we are seeing. They are playing important role, and they are converting this biomass into the settleable form, which will get settled into the secondary sedimentation tank, and the part of the sludge is taken back into the system, and this sludge which is enriched into the microorganisms, they are causing a purification mechanism. Okay, and where they are going to convert this biomass, and this biomass it will get settled into the secondary sedimentation tank, and where it will be get removed, and you are going to have the secondary effluent which is defined by the Maharashtra Pollution Control Board or the CPC. For example, the outlet BOD should be 10 milligrams per liter. Then the COD value, it should be the 50 milligrams per liter. The MPN value should be nil. Then the total dissolved solids in organic, they should be below the 30 milligrams per liter. So these are the cross-checking parameters which will be checked. Now we are going to see some case studies, 2 case studies I want to showcase with you. So through which you will understand how the treatment is occurring at that one. So the first case study it is for the Pimpri-Chinchwad Municipal Corporation, and this sewage treatment plant is constructed by the HN Butt. So this is one of the company, and they are specifically working in the domain of sewage treatment plant, and they are having a various treatment facility across the India, and they have modified. It is a combi treat, which is one of the modification of the activated sludge process. Okay, so through this video you will be able to understand how exactly the purification or the impurities they are getting removed.
Private Limited is a leading EPC contractor engaged in wastewater treatment technology, started on small scale by Mr. H.N. in 1973. The organization has now grown as major player in wastewater treatment works. Since 1984, the organization has concentrated on wastewater treatment technology and now has 25 years experience in the field of wastewater treatment and engineering. During this period of 25 years, the organization has successfully constructed more than 50 such treatment plants of diverse magnitudes for a wide range of clients. The rich and valuable experience accumulated by the organization's core team over the years has enabled introduction of numerous specialty technology, considering the constraints of flow, electricity, and space. While executing diverse projects, the organization has successfully handled processes such as extended aeration, activated sludge process, gas and aeration process, bio-turner technology, that is attached ground process, sequential batch reactor process, and packaged treatment plant, etc. The presentation which you are now viewing is a plant in wastewater combi train technology. This is cutting-edge technology in wastewater treatment. Of the universal shortage of plants and bar and skid back bar to operate the plant. This will be a patent technology of the organization, and application for patent for combi treat technique is in process. process of sewage treatment irrespective of the technology adopted, along with a patented unit of Gombe treat. The individual units are raw sewage sump and pump house, primary unit, patented Gombe treat unit, hydropower generation unit, chlorine contact tank, chlorination room, sludge thickener, centrifuge platform, biogas-based generation unit, administrative building. The schematic representation and sequence of treatment raw sewage to sump, removal of floating material, chamber about 20 mm size, removal of floating material, screen chamber about 6 mm size, removal of inorganic matter of specific gravity greater than 2.65 and particle size more than 0.15 millimeters in grid removal tank, biological treatment, and generation of electricity, generation of hydropower. The discharge and outlet enables the same to be used for gardening, industrial purpose cooling tower, car washing, or other purpose than human consumption. After entering into raw sewage sump, chambers where particles about 20 mm size are separated and removed mechanically out of the sump. Removal of material at this stage increases working life of the pump. The liquid, which is now free from large size solids, is pumped to the primary unit. Remaining separated by the above process can be used for dumping, landfilling, etc. The liquid received at primary unit is fine screened to remove floating particles of over 6 mm size and then passes through the unit grid chamber where inorganic matter is separated. At this stage, the sand gray particles are removed from the system with the help of mechanical screen. From primary unit, sewage will now flow to central zone of Gombe treat unit from bottom. The outlet ladder being provided at periphery and at the top of unit, the liquid will flow from bottom of Gombe treat unit towards top of the container, from where it will flow out to the CNSPR tanks for its aerobic treatment. At central zone, during the time of traveling liquid from center to periphery, sludge particles will settle and settled liquid will only go out. The settled sludge particle contains higher concentration of pollutants expressed in terms of BOD, COD, etc. The comparatively weakly polluted liquid will flow out to CNSPR. The principles of this system is to treat heavily polluted sludge anaerobically to save power and to generate biogas as fuel. Are mixed thoroughly, which enables generation of biogas. The methane biogas generated in the process at central anaerobic zone, being light in weight, will flow upward and will be collected at central dome portion. The dome is a facility of moving up and down to accommodate variation in volume of biogas. The overflowing liquid from central zone will receive at CNSPR tanks for treatment in batches and in sequence or period. Settle and discharge fill. This is a constant level method. CNSPR technique does not demand any loss in head during process of treatment and discharge. Hence, constant head is available at discharge point, which is utilized for driving turbine for generation of hydropower. The biogas collected at central dome will be used for generation of electricity by providing biogas engine connected to alternator. Excess sludge generated within the system will be thickened and thickener before passing the same through centrifuge for dewatering. Treated water coming out of plant after driving the hydropower turbine will be disposed of after giving chlorination treatment and chlorine contact tank. The highlights of the project are are excellent outlet by design, lowest power consumption than any other method of treatment, having guaranteed output, capacity of hydropower generation, capacity of generation of power from biogas. Total power generation is up to 80% of power required for sewage treatment and minimum manpower for operation and maintenance.
So this was a case study for the Pimpri-Chinchwad Municipal Corporation, where you have seen the technical highlights of the combi treat. Now, as an engineer, always there is a scope how you can increase the efficiency, how you can reduce the footprint, how you can generate the electricity or energy from it. Okay, how you can do the mechanization or the modernization, how you can reduce the footprint. And there are so many till challenges are there. Okay, so as an engineer, whereas in a for your third year or the final year project, you can work on the one component or the various aspects. So where you can provide the solutions related to it. So as you have seen, this case study is for the urban area where the population is large. The quantity of wastewater generated is again large and all these things. So there was one question: if this much wastewater is generated, then does that much treatment plants are available? Now the scenario of India is changing. Looking towards the waste or the wastewater is changing it. Now this is another case study you can say which has been mentioned. How a sewage treatment plant in Nagpur saves 190 million liters of fresh water per day. Okay, so they are treating it. The best example, another I want to quote here, the Singapore city. So initially they were entirely dependent on the water from the external, and they were purchasing the water from the Malaysia, just like we purchase the petrol, diesel, and all these things from the oil countries. The same way. But nowadays, they are able to convert the sewage into the drinkable form, and they need not to purchase the water like we are purchasing the petrol and the diesel. So that kind of a cottage technology they have developed, and yes, it is possible for you also. Now here the World Bank, they also consider the best water from waste to a resource. Okay, so actually it is not a waste, but by using the scientific things, technology, and the way of looking towards it, we are going to convert into the resource form, which can be used for the various purposes. So the World Bank report, it is also available there. Okay. Another thing at a central level, at Government of India, there is one organization that is National Environmental Engineering Research Institute, that is a NERI. It is one of the well-known government organization through the CSR, and they are also having various sectors of the environment. And one of the sector, it is related to the wastewater engineering, and they are working in this sector, and they have come up with a technology that is called as a phytorid technology. And this technology, it is an eco-friendly technology or the eco-technology, and that can be used for the decentralized system. Small areas or where there is an electricity problem is there, energy problem is there, finance problem is there, the skilled labor is problem. In such cases, this kind of a technology, it can be used very effectively. Okay, now let's see, actually they have demonstrated for one of the area. Okay. So in which they have implemented this technology, that is a phytorid. Okay.
Phytorid, a wetland system-based sewage treatment.
So I am sharing this video with you. So in which they have elaborated all the part functioning of the phytorid, how it is working.
Treatment technology. Water conservation is indeed the need of the hour. With the rising population in our country, recycle and reuse appears to be the only solution. If not, the war for waters is almost inevitable. CSIR Needy, with its commitment towards water conservation, has evolved a natural process to recycle and reuse precious water called Phytorite. A solution that involves no chemicals, that runs 24/7, 365 days, and the process goes on and on. Nature has given us enormous fresh water, which we turn into wastewater. That needs filtering, cleaning, and decontaminating. This is where CSIR Needy stands tall with Phytorite. Nature to nature naturally. It's safe, economical, and environment friendly. Based on wetland systems, a group of selected plant species not only absorb nutrients from wastewater, but also decontaminate the same, making it reusable without any chemical process. A user-friendly technology that works best on decentralized plant systems can be used for domestic or industrial wastewater. This system uses gravitational force to circulate the wastewater while selected plant roots do the cleaning process. A simple mechanism, yet robust with its outcome, where anaerobic and aerobic action goes on simultaneously with the support of biochemical reaction that eliminates contamination almost by 99%. Nature to nature natural is the basic principle of this system. Simply a great technology that involves material available everywhere, works where electricity is constrained, provides solution to recycle and reuse the wastewater that works 24/7, 365 days, and the process goes on and on.
So this was the technology developed by the CSIR Needy. So as a civil engineer, there are again so many lot of opportunities are available, provided that that kind of knowledge or you are having the information about that and you have work on this one. So even if you come up with such kind of a solutions, you may develop your own kind of a technology, uniqueness, because there is always scope for the improvements and all these things. So this is a research organization and they have so many come up with the technologies for the common community. Okay. So this was another example of a Phytorite. Okay. Now, what is the use of all these lectures and all this? It comes to the money. It comes to the question of a survival and all these things. So when I was preparing the presentation, I thought that these are the top 8 companies in India. They are related to the wastewater engineering, and they are having so many wastewater treatment plants for the government sector, private sector, and it may be for the other NGOs and all these things. So where having a knowledge of this domain, you may get absorbed. It may be Vatic, Babac, or it may be a Thermax, GE Waters, Siemens India, Aqua Innovatives, Hindustan, then UME India Private Limited. And there are so many companies are there. So just top 8 companies I have considered. Even at an international level, so if you are focused and having a domain expert knowledge and that one, so think big one. So it is possible. So this is a list of the wastewater treatment companies in the world. So they are very having in terms of a turnover, in terms of a technology, in terms of a establishment. So these are the various companies. And it may happen that some of you may be there in these companies, and you may take some kind of a session for your So let's come to the last point. As I know, your lunch break is going to be start at after 1:30. Okay. So as in this session, we have started with the importance of water, life, then its characteristics, quality parameters. Then we have seen the water by the wastewater. Okay. Then how it is related to the health challenges, problems, and what are the quality parameters for the wastewater. Then we have seen the type of treatment technologies with respect to the preliminary, primary, secondary, and tertiary. Then with respect to the physical, chemical, and the biological. And out of that, the scope, it was kept into the eco-technology, which we have seen. Then we have seen the classification based upon the regions where it is required. There is urban, semi-urban, and the Gramin or rural areas where how this technology. Then we have seen the mechanism or the microbial mechanism through which the purification is occurring. What happens inside our stomach, or indirectly you can say happening in the aeration tank or where the purification is occurring. After that, we have seen the case studies, 2 case studies for the urban areas and the rural areas, which has been developed. And with this, let I come to the last point. No water, no life. No blue, no green is going to be there. And you, as a civil engineer, you are going to play an important role in the infrastructure. And you are a small contribution, which is going to be visible, that is going to make a lot change. Okay. So with this, once again, thank you to the organizer, Priyanka Golap madam, for giving me an opportunity. And yes, all the students, so I'm able to see almost 40 students are there. Okay. So I will be very happy to have a question answers and anything. And even I will be very happy to work collaboratively with you. Any idea, any thought. So I have shared my mobile number and email ID with the Priyanka madam. So you can call or text me message for this topic. So we jointly, we can work and we can come up with the solution. So thank you. So over to Priyanka madam and the students for the questions.
Okay. Thank you very much, sir, for giving us a very nice and such an informative session and guidance to our students. Any questions from the students? Okay. So now okay, yes, sir.
Yeah, students, I will be very happy to listen. Due to, you can say, a pandemic situation, I'm online. Otherwise, as I said, a few years back in 2007, I was there and offline. I had a visit with the students. So always. But though it is a virtual media, so but as a human being, we are living things. So we are interconnected to each other. So I will be very happy to listen some feedbacks or the questions. So that I will thought that I am not taught to the laptop. Or
okay.
Yes.
Okay. So now I request to our HOD, Professor Satpute sir, to give a vote of thanks.
Am I audible, ma'am?
Yes, sir.
Yes. A very good afternoon, all of you. It's my pleasure to propose a vote of thanks on behalf of Samarth Group of Institutions, College of Engineering. I would like to special thanks to our chief guest, Dr. S.T. Mari sir, Head Department of Civil Engineering, PCCOE Pune, for accepting our invitation and giving valuable time for us, sir. Thank you very much, sir. Yes, we are very familiar with Dr. Mari sir work, and here is a very nicely illustrated importance of eco-technology for waste treatment. We will take in account all the suggestions, guidance given by you, sir, in the area of wastewater treatment technology. Thank you very much, sir. I would like to thank our management, Principal Dr. A.J. Patil, sir, Administrative Officer Professor Gadekar, sir, and all the members of the department for their support. I am also thankful to Golap madam for organizing today's session, and thankful all the participants for your presence and patience. Once again, thank you, Dr. Mari sir, for enlightening minds of our students. And I am sure today's session will be definitely helpful to our students in future. Thank you very much, sir.
Thank you very much, sir, for giving a response to our request. Thank you very much, respected Mari sir. And with the permission of principal sir, HOD sir, and Dr. Mari sir, we can conclude this. This session is over.
Hello, madam. Can I?
Yes, sir.
So I want to listen at least one or two students what they want to say. Yes, students.
Okay.
Because students, as you can see, entire all these things starting from your principal, sir, your HOD, your madam, they have taken a time even to have a discussion with you. So something. So as a representative, some of you can speak. Or even I request some Praveen Satpute sir, you can request some of the students. Just 1 minute of few seconds.
Anyone? Akshada?
Because today only I talk with my class of a TE Civil that along with the technical, your presentation skill, communication skills and the presentation skill, they matter a lot. And here you have gotten an opportunity to have present and which will be memory to me also. Just I said in 2007. So I will remember the name of that student always. Yeah.
Akshada?
Okay, from third year, Akshada.
Hello. Thank you, sir. Very nice session. The session is very informative. Thank you for giving your valuable time for us.
Thank you, Akshada. Yes. Any another? Okay, madam. Can we have a one group photo which will be memory to you and me also? And
yes,
requesting to all the participants to switch on your camera. Madam, I think you are taking a snaps.
Okay, sir. All participants. Okay. Please keep your audio, video or camera on.
Thank you for very nice presentation. Very informative. Thank you for giving your valuable time.
Okay. Okay.
Madam, kela ka?
Okay. Thank you very much, sir. Thanks once again.
Thank you all of you.
Thank you, sir.
So I will leave the meeting.
Yeah. Yes, sir. Yes, sir.
Okay.
Yes. Okay, thank you. Now we conclude that the session is over. Okay. Thank you, all of you.
मळ्यात